Okay, we're good to go. Okay, welcome everyone, and welcome to the 4th annual now symposium from the Visualization Interest Group at the Turing. I need to go around and thank a number of groups for supporting the meeting yesterday and today. The first one is, of course, King's Colleges for letting us use the room. And the meeting itself is supported partly through CUSP London, which is the centre that I'm director of here at King's, where we work on interdisciplinary research in informatics. And it's also supported through the Alan Turing Institute. So while King's is not yet a member of the Alan Turing Institute, we're part of a Turing Network Development Award, which is expanding out potentially to include us. And that project's funded part of this meeting. So thanks to all of those associations. My name is Nick. I think many of you know me already, and I joined King's very, very recently, and in this beautiful building, which we moved into in 2019. Just need to do some couple of pieces of business, and then we'll get going. So you might not know the Queen was patron, and King Charles is now patron of King's College, and so the college has asked us just to take a moment to reflect on the events of the last week. We'll just do a minute of silence in respect of the Queen. So, and if you feel moved to, there's a book of condolences in the foyer on the way in where you came in on level 1, and you're quite welcome to sign it, and it'll be sent on to the palace later in the year. This picture, if you wanted to go up to the same location, is on level 8 of this building, and there's a great view across London, right from east to west, on the day the Queen was here to open it. Okay, some more normal announcements. Look after yourselves while you're here and take care of others. There's various rules that we'd like you to follow, but just behave in a normal, safe manner, really. If you hear a fire alarm, you shouldn't. There's no alarm practice today. Please just leave the building out straight through level 1, through the main entrance, and the assembly point's on the other side of Aldwych, just over the road, but there'll be fire marshals to guide you outside when you get there. You won't need to use any lifts to get there or stairs. It's just straight out of the door. In terms of first aid, probably the easiest thing is to contact Clara or myself if something happens, but if there's an urgent assistance need, you can contact the central point on 020 7848 2222. So on to the main business of the day and the 2 days here, really. So the Visualization Interest Group at the Turing started 4 years ago when Patty, Holly and I proposed to Turing that there should be a visualization interest group in the UK, and luckily they've supported it continually since then. And someone's got an echo. over that time, we've done a number of activities, and one of them is to build up a landscaping document, a very short description of what we think visualization is in the UK, and we've used that to influence policy at the Research Council level. So one of the things we managed to do, which came out only a couple of months ago, was eventually, through various routes, persuade EPSRC, the main funding body in the UK for science and engineering, to put out a call for grants in visualization. And a number of people in the room have indeed written those, I think, and they've gone in. And hopefully some of you will win them, and we'll do more visualization research as a result. And that's really one of the points of the Visualization Interest Group, apart from bringing people together and meeting. And we've got a few projects going on now, similarly to the future, trying to expand the amount of people working in visualization in the UK, build up the PhD base, build up the academic base, and also link out to industry. And so there are some industry people. Yes, there's at least one industry person in the room linked to Imperial. And I know there's some others online from various organisations inside government and outside government. So one of the purposes of this week is to try and refresh that landscaping document, to push it back out into the research councils and into government, and take hold of some words that Patrick Vallance, the chief scientist in the UK, said, which was that visualization after the pandemic had become clearly demonstrated to be an essential thing for the UK to have more capacity in, and it had become an essential part of the communication in the pandemic. And so understanding visualization and how to do it, the science, design and engineering behind it is very important. So I hope the ideas from this week will help us rewrite the landscaping document, and we'll feed that back to people who are interested later in the year. Certainly be on the Turing website, and we'll be able to use it in a number of ways. And with that, it's my very great pleasure to introduce Min Chen to talk to us. I'll drop off the sharing in a minute, but I'm going to tell a story about Min that he may not know, because only I know this story. A long time ago, a professor at Oxford called Anne Trefethen asked me to write a job description for a post at Oxford in visualization, for professorship in visualization. Said, Nick, it'd be a really great idea to write this and then apply for it. And indeed, I wrote the job description and applied for it, but someone else got the job. and luckily for me, it was Min, because I couldn't be disappointed at all, because he's an excellent visualization researcher and has done a lot more good than I have in the field of visualization. So with that, Min, I'll stop sharing my screen and you can share yours, I hope. Ooh, press the wrong button. What's good? Oh, perfect. Right. Okay, Min. Do you want to unmute yourself?
Thank you very much, Nick. And I didn't know the story at all, and really honored in a way, and being appointed in this way. And thank you for the kind words. So I would like to take this opportunity, probably to add a little bit more information about the UK landscape in terms of visualization, and maybe have a brief look at the challenges and the opportunities in the way. I will probably start with the Viz contribution to the pandemic in the UK, and see sort of how our activities really tell us about the Viz in the UK. And I will then move on to the Viz area model, which is relatively new. And I was part of the revised committee in terms of creating this particular model. And so I would like to share a little bit background knowledge with you. And through the lens of these 6 areas in the new Viz model, Viz area model, so I would like to look into the UK expertise and the various challenges maybe in these areas. And of course, at the end, I will look at a major challenge in the UK and in terms of operational level for data visualization. And many of you are part of the RAMP Viz activity, and some of you probably have heard about that. And during the pandemic, and most of the Viz colleagues in the UK and managed to get together and volunteer to help the modeling scientists in their effort to create models which can sort of relatively accurately predict the pandemic, the trend of that. And these are volunteers, and some of them were appointed with the grants. Very briefly, in May 2020, and we started calling the Viz volunteers. We realized modeling scientists need a lot of help, and within about 14 days, and 22 Viz volunteers, Viz colleagues volunteered to help, and we organized into teams, and within about 3 months, they developed a server which is become deployable with a lot of plots and the dashboards, while the many others will continue to work on the analytical algorithms as well as a more complicated visualization and visualization software. By 2021 February, and sort of quite about 8 or 9 months later, and we have received the funding for a year. We employed a number of researchers and are working on the software side to try to deliver various sort of designs related to the pandemic models. And so far, by today, and there are 7 research papers have been published. So you can see the amount of work generated within that relatively short period, with less than £500,000. The funding is very impressive, and I'm certainly very pleased by the colleagues and made those contributions. In fact, there are at least 3 or 4 other papers are currently under review, so hopefully there will be more coming up. So what does it tell us? It tells us we have a strong collection of visit academics in the UK, because most of our volunteers are actually academics. And they're distributed across many universities. The largest cluster have 4 people, and many have only just 1 person in the university. The research quality in general is quite good, and we only need looking into, with a small amount of funding, their research publication come out of the RAMP with this project. They've managed to deploy, sorry for the spelling mistake, I've been writing slides, deployable software. And I'm going to talk about the broader subject coverage and today. So in fact, the coverage is again quite impressive. A lot of international collaboration, but on the hand, the visa operation in the UK is underfunded, and with kind of an inadequate number of PhD students and the postdoctoral researchers. And this reflected in the RAMP viz operation. We actually struggling in getting the PhD students and the current postdocs to be involved in terms of developing software. Let's have a brief history of visualization. And of course, visualization used to be called the statistical graphics in the way. And around the late 1980s, and Marching Cube was developed, published in 1987. And then later in 1988, a few papers on volume rendering. And then later, in fact, Mark Lavoie's paper in 1990, and really generate a lot of interest in visualization. So visualization, IEEE visualization was created at that time, and the later InfoVis, and later and the VAST. You can also see the Eurovis follow the trend of the IEEE visualization, and the InfoVis again was created around 2000-ish time. And after a while, the 3 subjects and the Viz, or later being called the SciViz, and the InfoViz and the VAST, and started to discover there's a fair amount of overlapping and also maybe a little bit unhealthy competition in terms of for papers. So the operation started to combine these 3 conferences, hopefully in a way to reorganize 3 conferences into a single one. And Chris Johnson in Utah and suggests they use the acronym V for VAST, and I for InfoVis, and S for SciViz, to call the conference IEEE Viz. And in fact, as early as 2016, a few senior colleagues, I certainly wasn't involved, and behind the scene, we started looking into the restructuring the Viz. And I was called in to help in 2019, and in the second advice committee. to look into the detail in terms of area model, organization structure, and keywords, and the submission and the review processes. And here I'm going to only concentrate on the area model, and for detail, you can also find on the web page as indicated here. And people are actually quite excited. People in the committee are excited about different area model. Everyone has their views. A total of 12 area models were actually proposed. 4 of them are shown here. And then you can recognize some of the thinking behind it, and certainly the theory, and something about the people, the human side, and solving the real world problem applications, and the engineering systems, and something about sort of analytics, and something about algorithms and techniques. So very kind of in some way similar to the visit paper types before. There were also suggestions related to applications such as life science and the digital humanity and the various other things, finance and so on. And so there's a lot of discussions about discussion and debates about the various area models. And we also try to make a connection to see how the original, the VAST and InfoVis and the SciVis in terms of addressing those topics. And naturally, people thinking about the data types, and here's a diagram drawn about the various of the data types. And very quickly, and we realize if we organize the area models based on data type, and we will go back to possibly the older model, sort of a SciVis deal with the volume vector and the tensor, and the InfoVis deal with sort of a text data, tabular data tree, and the graphs, and the geospatial data, and the VAST never know exactly what they're dealing with, and so on. And so that was ruled out, and after a few weeks. And we also look at the in terms of applications, and we realize there's so many different applications in the Viz has been so far worked with. For example, SciVis tend to concentrate on the mathematics, physics, science aspects, and the InfoVis and the concentrate arts, humanities, social science, healthcare, and the biological science was sort of addressing both ways. Sometimes the imagery data goes to SciVis, and the more informatics data goes to the InfoVis. Then the VAST comes in, started bringing more emergency resilience data science and the law enforcement, security, and so on. And there are many specialized workshops tend to deal with and one or two strand of applications and so on. Again, we realize if we sort of started to using applications to divide the subjects, we still somehow couldn't quite sort of break it away from the SciVis and the InfoVis and the VAST way of sort of a division. So there's probably one particular proposal suggests about 12 possible topic areas. And the suggestion actually is quite kind of a simple in a way by taking the common element of theory and the empirical studies and the applications as sort of a more general topics lifted out from the 3 conferences, then to see what type of things are remain in the 3 conferences. So we notice InfoVis tend to have a more visual representation discussion, more about interaction, the collaboration, and the communication, storytelling, non-photorealistic rendering, and so on. And we also noticed the SciVis tend to deal with more system side and much more about the algorithm for extracting information from really complicated data and dealing with more rendering techniques, or here it's called display techniques. And visual analytics deal with algorithm and visualization, how to integrate together, how to optimize the use of algorithm and the visualization and the interaction, and look at decision support. And in the recent years about the machine learning and the other model development in some way. And we also take an opportunity to look the the 9 area, which is apart from the generator, to see actually how they related to some other aspects inside the viz and aspects outside the viz. And in terms of inside the viz, we look at the 3 components: user and the data and the tasks. And we map the areas, the topic areas. We start to notice actually InfoViz tend to really like users, and why SciViz really like data, and why visual analysis tend to like the tasks more. But nevertheless, everyone claims they like everything, and but there's a different emphasis in that way. Externally, and here's a marked as A, B, C, D. We're looking at the external sort of the vantage points, and we notice again we can see the aspect which is the human knowledge and the driven the data intelligence, which is the A, and that tend to be focused by the InfoViz and the visual analytics, which is they tend to work on this area a bit more. On data-driven intelligence and again the SciViz and the visual analytics tend to be happily working with sort of hard algorithm problems and so on. And on the communication side, how to communicate the data to the people, and we notice the InfoViz and to a certain extent SciViz also have this kind of emphasis on in linking but the communication aspect. So in many ways, the evolution of 3 the subjects, the SciViz, InfoViz, and the VAST is not totally arbitrarily for some sort of a non-scientific reason. They do have some scientific background and so on. So the idea is that when we do divide the the areas in the Viz community, and we still need to capture those kind of emphasis in some way, and instead of sort of totally kind of make a stir fry of it. And based on the 12 topics, we also annotated the Viz papers. So in this particular case is the Viz 2018 paper. All the papers published in the Viz 2018, we consider what people might choose as the first area, what people might choose maybe the other optional areas, and we calculated a statistic to estimate how many the papers per area may be. You may notice that, and clearly some areas do not have many papers there. So some as a 5, as low as a 3 and a 4, and so on. So naturally means some kind of merge or combination the area will evolve. So and you notice that the theoretical and the empirical research being combined into the theoretical and the empirical research here, and application, and we particularly give a single area try to encourage that. So we also anticipate the paper may be considered as sort of visual design paper, may be considered as a visual analysis paper, may quite happily moving into the application area. And we particularly put the system into an area where anticipated the number of papers may be relatively small in that particular area. However, we really would like to encourage that. And we also move some of the techniques a little bit closer to the system on the displaying side, the rendering side, and as well as some of the layout algorithm. So we move them, combine that with the system rather than move the area afterwards, referred to data transformation. Area 4, focus on visual representation and the interaction techniques, is fundamentally the core business of the InfoViz used to consider. And area 5, data transformation, is looking into the algorithms about how to move in one type of data to another type of data. For example, moving from volume data to surface data, and extract the tensor topology from volume data or flow vector data. And this kind of data transformation essentially is the one type of data moving to another type of data, and in that way enable visualization to visualize the original data in a kind of a different type of data form. And we really would like to encourage some of the InfoVis type of problem also consider their data transformation as a kind of algorithms, and they find a home in that new Area 5. Area 6 focus on the integration of algorithms and the visualization interaction and the statistics, and particularly looking into how to design the workflow with all those components were combined together and then maybe design a relatively optimized workflow. And we consider the latest development in terms of machine learning happens to be an important topic, and because itself is a very, very complicated workflow, and how we bring the visualization and the visual analytics into those. So that's again the core sort of the visual analytics. After a number of iterations, and the name eventually converged into, as you see in the VIS 2021 area model published officially on the web page. So now I'm going to very quickly, so I'm not going to give a detailed description about each area, but I'm going to concentrate on what type of research involving that, and what type of work and in the UK actually happened in those areas. And for area 1 is including mainly 2 areas, theoretical work and the empirical research. If you notice that theoretical work is not just about the mathematics, it's about concept formulation, including surveys, taxonomy, ontology guidelines, and so on. And also about looking into the models and how to consider how human may work with visualization and linking certainly with the empirical research later on. And in the empirical research, and we're taking the research methodology, including grounded theories and some other methodology, and as a part of the framework for consider they are the overall sort of a research agenda in this theoretical empirical framework. And empirical studies, and if you notice, is including controlled, semi-controlled, as well as uncontrolled studies. And for the first time is to we spare out the purpose for those empirical researches could be for evaluation, which used to be considered as the only purpose, but now we consider it's one of the 3 purposes. We give emphasis to observation, data acquisition, and the hypothesis formulation and the evaluation. And we also would like empirical researchers to provide a sort of a way to understand the theory and to validate the theory in a better way. And the UK play a huge role in providing the surveys, and this is just for CGF alone. I had a quick scan about all the state-of-art report published 2020 or before, so I have got a chance to collect the latest data. And you can see a few colleagues are extremely good. You notice the name Rita Bogle and Bob Bellamy, and has been sort of 2 big sort of contributors in this particular area. And I know there's other survey paper published in the TVCG, for example, Jonathan Roberts and a few others, colleague I may, but yeah, apologize if I have missed anything, but there's many surveys. So that also part of reflect the amount of knowledge we have in the UK about the whole various of the subjects in the VIS community. And we also have quite a few taxonomy and ontology and design space paper. I took opportunity to reach the slides and which my colleague in Statistics Netherlands and Martin Tenkes and I sort of illustrate the taxonomy and ontology and the design space in this sort of a more visual way. And basically, if you think about a various sort of articles you can discover about visualization, if it's a taxonomy and you try to group those papers into a tree, then any sort of techniques, anything topic, and you will throw into one of the branch or one of the leaf nodes of the tree will be somehow there. And if you're developing some new techniques, and you can possibly have to try to find a way to see whether which branch it belongs to, and so on. The ontology try to avoid this kind of overly structured way of thinking by simply putting all various of entities into a node. Of course, you can also group them into a cluster of nodes. Then you try to draw the connection among them to say, oh, these are similar in certain way, and this may share the same data type, and this may share the same algorithms, and this may share the same visual representation, and so on. So you can looking into the connections among various other techniques and so on. Then naturally, and when you try to identify a new design or create a new design, and you may start thinking about this new design may be related to some other existing designs in this particular ontology. And the design space, and actually people sometimes find it hard to explain designs, but it's become so easy to explain to visualization people. It's essentially it's just parallel coordinates. And if you divide your the various of design attributes into various of dimensions, so they become an axis in the design. So various of options in each dimension become a position along the axis. For every single technique, and you can sort of draw a line to connect the things together. And then you can explore a new design by identify maybe the pathway hasn't never been connected before, or alternatively, you say there may be a certain dimension, there's a kind of a position missing, and we should create a new position there, and so on. So it is particularly useful for organize your design and to identify existing design patterns, as well as to potentially imagine what a new design may look like. Recently, and Benjamin and Ewing and Freeman and a few other colleagues in the RampViz project built their knowledge about the dashboard during the RampViz project, and conducted a survey of various of dashboards and organized their design into the design space. And you can vaguely see there's a two block of attributes, and you can easily see these two block of attributes can be organized into some kind of a parallel coordinates by consider every dashboard is linking together in that way. And on the left, it is actually to do with each components on the dashboard. On the right is to do with how the composition of various components related to the dashboard. And in fact, you can easily think about they may need a more complicated visualization to bring the lower level, the design space, which on the components and the linking with the high level. And so on. I'll leave you to imagine how the visualization may look like. And as I talked a lot, and RampViz colleague actually really familiar with that particular scenario. When we first be asked to working with the modeling problems, we've been given a task about communicating the modeling results to the outside, and if you notice, that's the viz, the nodes where supposed to be located to. And during the first meeting, I made the argument to say they need more support about visualization in various aspects of the model, including the evaluation models, or even observing the data even before the modeling, and the very other things. And Professor Richard Reeve from Glasgow University was extremely open-minded, the domain scientist I ever worked with in a way. And he was so open-minded in the sense, yet within an hour, he just say, yeah, here, give a go. And within a day, and he redrew his picture, as you see on the right. And later on, and we summarize the effort in terms of how we organize many visualization people together, and we organize them into 4 teams, as you notice, the storytelling on the disseminated visualization and the genetic support and analytic support and the modeling. It was very much based on the 4 levels of visualization proposed in the 2016 paper, based on algorithm sort of a complexity kind of a way of thinking to think about task complexity for visualization. And we also, in our way, to organize the people in terms of resource required for the people in different teams related to the task complexity. And in addition to the 4 levels of visualization proposed in that paper also challenges us to thinking about the visualization, because every time we talk about visualization, we always talk about visualizing has this weakness and that weakness, this information is lost, that information is lost, whatever the case. And then since the visualization seems always losing information one way or another anyway, and let's go even a little bit further, and we actually notice statistics and the algorithm also losing information. So can losing information be good? And if we sort of divide the good points about losing information and the bad point of losing information in a way, and we can call them different term, and we can call them alphabet compression, which is really to make things a little bit simpler, or abstraction in other words, and the potential distortion. There will be also a balance act related to the cost in terms of a computational cost, as well as the human cognitive load and the other aspects of that. The model, this particular mathematical model, will work with a information scientist and economist, Amos Golan in America, and he naturally, using his economics background, he said, "Oh, that should be called cost-benefit model, or cost-benefit measure." And we can measure the mathematically the top part using the information in bits, and the bottom we can approximate with the time cost and the financial cost and so on. And based on this thinking, we can also work out how to actually potentially optimize a workflow involving the statistics algorithm visualization and the interaction in a hopefully the measured or quantitative way, but certainly we can do it in a relatively qualitative way now. And this was reflected in a work done with a colleague in US, David Ebert, as most people probably heard. And he actually is the general chair for the coming the VIS conference in October. So on the whole, you can see the way of thinking is, say, the trade-off between statistics and the visualization algorithm and so on, and also the balance between the information loss, which is the good point, on the bad point, the balance among the benefit and the cost, seems to always sort of about looking into the kind of can't quite decide exactly what to do. To a large extent, I actually struggling find occasionally to convince colleagues to thinking sort of visualization and the visual analytics in this sort of a balanced and trade-off way. And in recent days, and when I was watching the BBC World News about the history of Queen, then I noted, and the Queen actually had a wonderful piece of speech and really explained how sort of this balance the view about events. And if excuse me, I can probably quickly just repeat it and say there's no point in regretting the passage of time, and the growing old is one of the facts of life, and it has its own compensations. Experiences should help us to take a more balanced view of the events and to be more understanding about the foibles of human nature. And it's almost spot on in terms of visualization, because if you think of the visual events are just various phenomenon of visualization processes, and we do need to understand the human in terms of a combination. So I take that point, and I'm hoping a lot of colleagues, when they getting older, they will probably appreciate the balance and the trade-off, and even better than I do today. And we have a number of empirical study experts in the UK, and namely Rita Bogo, Afi Abdul Raham, and Nick Holliman, and they all published several sort of first authored papers on that topic. And we also have a Dan and Aidan and many probably other colleagues, which I couldn't quickly find all their papers and being done empirical study. And I noticed that with Nick joining King's College London, now King's College probably will have become the center of the world in terms of empirical study. Hopefully that will happen in coming years. And although I'm personally involved in fair amount of quantitative side of research in terms of theoretical side, I'm having really encouraged the empirical side, the qualitative side of the research. And the two UK colleagues, Afi and the band, has been working with Alexandra in Manor. They're both used to be in Constance, but now in Switzerland, and to create this discourse website to discuss various of pros and cons and the visual guides. And in fact, Bob Lellamy and also Thomas and when living in Swansea, and also use that way to teach students and encourage students to involve in the discussion and so on. If you ever had a chance to look at the web page, it's really exciting discussion. It really makes you thinking about the balance and the trade-off, and in terms of various aspects of visualization, and really ask you the question: how should visualization guidelines be phrased and really be talked about, and so on. And another qualitative methodology is recently advocated by Jason and in the ramp with objects, and Jason encouraged everyone to really write notebooks, and I can't remember exact number, so over 20 notebooks being written by various of teams and so on. And then this will combine it together to produce the paper in the philosophical and transaction A, and on the reflection of aspect of the ramp with operation. And in many ways, the methodology is very close to the grounded theory about diary writing and the very other sort of qualitative methods that tend to be more commonly seen in social science. So those are wonderful developments, and you can see that UK colleagues are taking a lead in thinking various of theoretical aspects in a broader spectrum, from quantitative to qualitative, from empirical studies to the mathematical and as well as the conceptual formulation. Application, and we talk about the application in the define of the various domain of applications, the various application specific techniques, and then in the third element, hopefully we can see more on that, is the insight documentation. In fact, the Jason the operation led by Jason about a notebook can also be classified into that particular category about the insight documentation about that one particular application. And I can't remember any sort of major application as big as the ramp viz operation. There may be more they are existed, but certainly ramp viz isn't really a small application, and it has a lot of unique features which normally you don't see in other applications, and emergency responses, volunteering, and a large consortium, and a very large viz project with sort of 10 universities involving funding the funded projects, and many volunteers and so on. Collaboration is extremely hard in during the COVID, and the project produced software as well as many publications. So I think we should be proud in the UK, and we managed to deliver on that particular application in this way and achieve that. And UK colleague has been developed many other applications, and I here just showing one picture example, which is really a serious piece of software deployed in the International Seismology Center, developed by two colleagues. By now we're all familiar, and Hu Yifan and Safu Ken. And it really addressed the problem before they took on the problem. And visualization is largely in the form of a paper, as you see piles of papers on the top of that. And after that, there's a plot system allow them to almost get rid of a paper entirely. And there are many other applications. Hopefully some of them I may get mentioned a little bit later on. Area 3 is about system and the rendering, and this roughly divided into 3 sub areas. And the first part of that is really the systems for developing visualization tools or visualization software. And the second part is about the visualization systems themselves, such as apps and tools and so on. The third aspect is the rendering techniques. As you notice, they all mention the placement techniques and synthesis techniques and the various of fabrications and so on. And you can see a lot of exciting area potentially can be explored: the 2D, 3D printing, and the VR, and the mobile devices, and sonification. So there are many areas in that particular area. This area. However, we're also aware the papers published in Viz each year in the area is not great, and partially probably because developing system is really expensive and need a lot of expertise. And here and obviously the ramp Viz architects and the later on various of ramp Viz tools, and are a kind of an example to show actually how we deliver the usable software for the Viz. And also take opportunity to acknowledge actually Afi is one of the UK scientists extremely good in delivering the tools that can be used. And this tool probably developed, one is developed roughly about 10 years ago, and another developed probably 9 years ago, and they are still alive and are still working online, and they are wonderful systems, and coming out just about roughly about 1 year funding for each project. Area 4, we know Area 4 very well, and we talk about visual channels, and at the low level we talk about visual representation and various of visual designs and so on, and we talk about interactions. So I kind of leave it quite brief, and there are recently we talk about various of other visual communication techniques, such as focus context, illustrative visualization, storytelling, and text annotations, and the very other things, and so on. Intelligent visualization, which is look at the sort of mixed initiatives and using machine learning to help automate the various visualization process, and so on. We also have another area with, again, try to encourage people to have technical discourse on the visual representations, such as critique the visualization and compare the how to sort of compare the static and animated visualization in different scenarios, 2D and 3D, to have more sort of discourses on that, and as well as the visualization literacy. There are many expertise. Many groups in the UK have, for example, the City University specialized in spatial temporal data, and you see some examples, including this are actually their contribution to the COVID modeling visualization. And recently, the CGF paper, and you published in the Euroviz this year as an honorable mention by the Chatty and the Dance group, and looking into the contact tracing graph-based visualization. Those are the typical paper you will consider in the area 4. And there are many other areas. We talk about cities expertise on the spatial and the spatial temporal data, and the glyph-based visualization. UK actually is quite strong, and in fact, the retest the glyph, the survey on glyph-based visualization is still very much highly cited. The city, the Kai and checked his the work on the graph and network visualization. Storytelling visualization, we have the expertise from people like Ben and Jonathan, and lately panels. The Jonathan's coordinated multiple views. Also, we have a lot of expertise on volume visualization and the flow visualization, and certainly Bob is the internationally recognized experts. As always, we developed the idea for video visualization, probably wrote most of the paper on that particular topic. There are many other areas probably I have missed. Area 5, it is really concentrated on looking at how to extract the information and how to converting the data from one form to another, and how to combine data together, how to reorganize data into hierarchical, and annotate the data by enrich the data through deformation, labeling, generation, and lately related to the machine learning and the data wrangling and the improvements, machine learning for data transformation and the mathematical frameworks such as topology, computational geometry. And again, we would encourage people to have a more discussion about the data processing, and such as the provenance, and the very other sort of question about human involvement and the quality assurance and so on. Traditionally, and we have some wonderful work done on the algorithm side. For example, my colleague in Swansea and Mark Jones, some of you probably still remember him, and did a huge amount of work on related to voxelization volume rendering. And Hamish Carr is one of the world leader on topology and based the data transformation, and the Bob Lamley involving a various of vector and the TensorFlow kind of problems, and involving that. So there's a fair amount of algorithm papers produced in the UK. And in fact, the people tend not to think about those algorithm papers in terms of thinking they are visual design papers. And if you think about Joe's the OD maps and the retest, this sort of mapping, circular mapping, behind that, actually there were a fair amount of algorithmic work from converting the type of data they have to those kind of data. And I'm aware, and the Joe is also working hard on some more complicated algorithm related to those kind of mappings in recently. So those should be really considered as the algorithm work, and particularly from InfoVis point of view, or older InfoVis point of view, we should really find a place for them to get published, and hopefully the area 5 will allow this to happen. Area 6 is visual analytics. And people used to think about the visual analytics is just type of mixture between the algorithms and the visualization. And there are such work during the ramp visit operation, as you see here, and on the certainty analysis on the top, and the Chatty leading the group. There's a variety of time series analysis and so on. And they actually are become more complicated and became much more theoretically guided in the way the sensitivity analysis led by Rita and Hui and a few other colleagues, and Eric as the one delivered the design and the implementation, was taking the problem people used to do uncertainty analysis through a simplistic way, for example, plotting all the time series with various of predictions, and all using algorithm only to plot them with simple bar charts. What they did is to take in the two approach, and the one approach is to looking into how to use to enrich the algorithm by see the more detail which the algorithm cannot show. It's not just statistically to say one is better than another. And what we really want to show is in terms of sensitivity, do sensitivity changes among different values and not within its value itself and in the different part of pattern. And you can see the curved patterns you have, which indicating within the statistics, actually the behavior is not a uniform. It has a non-linear pattern, and which really the scientists would like to see. Then another alternative is to take a visualization as the main approach by actually grouping those time series on the left and into the clusters. Then you see, oh, those clusters are actually reflecting different type of predictions. What kind of decision making may be interesting? Are you thinking about a more flat curve or much more the kind of a curve in a way much more risk and so on? And you can actually observing what type of variables and in the variable space enable this different four clusters to happen. So you can look at the patterns to see what is actually the dominant impact in these areas and to see how that then and hopefully and the details can be discovered by most people during the Viz conference as Eric and have a paper there. And of course, machine learning is going to be a huge challenging in the subjects. I've said the challenging because we tend to thinking of machine learning is a kind of a magic solution is going to happen. But in fact, and for anyone working on machine learning, know that developing a machine learning model takes sort of months and months and in the way. And part of that is involving a lot of the kind of a guess which can be easily speeded up by using visualization because the machine learning colleagues not used to see the data and in a relatively quick way. And using visualization to enable them to observe the data quickly, which means they can modify their models quicker and improve their model in a relatively speedy fashion. The aiming is to hopefully, if we find the various of a different way to visualize different type of data stream during a machine learning workflow, and we can speed up the machine learning workflow much dramatically. In an ideal situation, and we're aiming for is if we can reduce the current commonly see the machine learning workflow actually takes 6 months to up to 24 months, some of them, and to reduce them to maybe a few weeks. And that should be the future aiming for. So visualization have a big role to play. And also theoretically, we know that, and in fact, in many cases, the data itself doesn't really provide the information. And if a human was involving in the process, actually information theoretically, and the human are actually providing a fair amount of information in addition to the information provided by the data. And again, the Swansea colleague Gary Tam, together with others, and published the paper in 2016, and that was the best paper in the vast to argue about human involvement in the machine learning process through a practical experience as well as information theoretical manner. In summary, and there are many things we can do, and hopefully, and we can work a lot more on the trade-off and the optimization from a theoretical point of view, and more cognition in empirical studies, and hopefully we can use the empirical study to discover more reusable measurements rather than just simply sort of do an evaluation, say box ticking exercise done. Kind of next time we have another problem, we do another empirical study. If the measurement can be reusable, and that would be great. And in area 2, and hopefully we can have a more science guided requirements analysis and evaluation, and in this particular case of the COVID, and we certainly notice, and the traditional requirements analysis usually takes minimum 3 months up to possibly and a year or a few years, in some older cases, and it's not really feasible, and we really would like to do requirement analysis and quickly, and also evaluation, and can using sort of a more scientific approach to complement the user-centered evaluation. And then we certainly would like a more deployable software. In area 3, lots to do, and we need a more deployable software. In order to have deployable software, we really need more and the PhD students and the more research officers who can write visualization software. In area 4, which to do with visual design, the challenge is actually how to reason the visual design, not just based on what the user wanted, but based on perception and cognition. And in area 5, and there are many type of transformations among different data. And in fact, during the revised committee, and we listed the slides for with a tiny small font to list all the possible transformation which we can think about. It's sort of it's gone over. Yeah, a huge long list. So ideally someone can map out all the possible mappings. I'm particularly looking at the colleagues who are particularly good at surveys and the state-of-art reports, me thinking that's the problem they could do. And area 6, and we tend to mix the algorithm, statistics, and visualization and the interaction in a kind of an intuitive way. And but what we should do is using kind of a scientific guidance to optimize the workflow. And in industry, and whether you do manufacturing or you do business, and we have a quantitative way to optimize the workflow for manufacturing pipelines and business processes. And for data intelligence, or in general, in terms of data analysis or data sciences and very other things, including machine learning, we actually don't have a proper way to optimize the workflow involved. So that will be the challenge for the future. In conclusion, and the research quality and the subject coverage in the UK for visualization is perhaps the best around the world, one of the best at least. In terms of education, it is great for educating a new generation of visualization scientists, as well as the data scientists who understand the viz. And however, there's no adequate support currently for PhD education in viz. And the distribution of academics across many universities in the UK is not always a helping fact. So the question for everyone, how to educate a new generation of viz scientists and data scientists in the UK. And I hope and you will find solutions throughout this meeting. Thank you. Hello? Are you still there?
Hello, are we here? Can you hear us now?
Yeah, I can hear you.
Excellent. So thank you for that brilliant, very well thought out, and will keep me thinking for more than the next week, certainly. So many things in there. We've got literally a few minutes before coffee break, and then we'll come back with a panel where we'll probably discuss some ideas more. I have one quick question, and then I'll ask the room for a quick question or two. One of the things that concerns me, I know Kasara's paper on us building our houses in visualization on sand with no real scientific evidence there. I think you picked up that really well. Another thing that concerns me maybe more is that the more broader public, certainly in the UK, is not educated mathematically enough to understand some of the things they're seeing. I wonder if you have any thoughts on what we do with the 80% of people who don't even have a GCSE pass at mathematics.
On that front, I think it's a gradual process. It's two-way. It's not just the UK problem. In fact, I was of course in the National Statistics Netherlands, and they encounter a problem. In fact, even more than what we think the problem is, because they tend to deliver a fair amount of statistics to the general public. And so naturally, in coming years, the education will be important. And also, it's important for the UK visualization scientists really to think about and how sort of what the visualization dissemination it is about. And the first thing, I really encourage people to separate the visualization for dissemination and the visualization for experts. And the difference is in two respects, and in one respect is the level of knowledge about the data between experts and between the general public is different. And the second thing is the tasks involving in observing visualization are very different. The domain experts tend to have very, very precise, sometimes mission critical tasks to perform after seeing the data, while the general public, often the task is undefined. And so if you can separate the dissemination from other tasks in terms of observation, analysis, and the model development, then that allows you to consider these two aspects much more, let's say, scientifically. And
yeah, so work for us to do, I think. Interesting more. Are there any quick questions in the room? Alyssa, press to speak.
Hi, Min, it's Alyssa Goodman. Hopefully I'll talk to you more about this next week. But I just have a question about a land between the real visualization experts and the general public. And I gave a talk in 2018 at the Viz in Berlin saying that these divisions between the different Viz sections were crazy. And so I'm super glad to see that you know you've harmonized everything. That seems to me a very inward-looking approach to the visualization community, and that's great. And then the question is, what is the outward-looking approach, not to the general public, but to the kind of domain experts who should know all this stuff, and I'm sorry, but mostly don't. And so I didn't see on the list there a field of visualization that was communicating to domain or with domain experts about how to actually deploy these things widely.
An excellent question, and in fact, through my entire academic career, I always find it's extremely challenging to ask domain experts not thinking visualization only just for producing their PowerPoint slides, and it takes a while. It takes a little bit effort. And in some cases, and for example, the seismological, the work, and when the companies, the organization involving, they do have a critical task in terms of getting rid of a paper and the speed up the process for human to do the job. And to them, obviously, the speed is related to the cost. So the people tend to listen more. And I mentioned in the COVID, and Richard was a wonderful person to work with, and it was just so open-minded. Although the initial idea was for dissemination to the public, and he certainly welcomed address the visualization problems throughout. How in general communicating to the other scientists involving that. In fact, there's another problem from a scientist point of view. I didn't mention that, is that most of the scientists, they are struggling with their funding. For example, epidemiologists, scientists, they never really had sufficient funding allow them to working with visualization scientists. There's a couple of richer areas such as the computational fluid dynamics and so on, but in most of areas, actually people don't have the opportunity to work with visualization scientists. I don't really know how to deal with that, and they will talk about a potentially bring back some of eScience model back again, and I know Nick want to hear that, and that particular there was some suggestions, but of course, and at the operation level is remain to see.
I would agree with Nick on that one, and I would urge commercial partners to.
Definitely. Okay, I think we're slightly over time, and we need to set up for the next step at 3. So, Min, are you going to come back later, or do you have to go?
I have a meeting at 4 o'clock, but I can stay on for a while.
So we're having a break now till 3 in the UK time.
Oh, okay, it's 4 o'clock my time. Yeah. Okay. Sorry, we'll have to miss it.
And then we'll move on to a panel session. Okay. Well, perhaps if you stay here, anyone who wants to have a quick chat online with you for 5 minutes might be able to do that while we all have coffee, and then we'll come back and set up the systems at 1:45. In the meantime, thank you all. Time for a break, and if anyone who's on the panel can come back at about 1:45, we need to set up cameras and things. But there should be tea and coffee. Yep, Claire's organised all sorts of things. And if you want to talk to Min, come and stand here and ask him a question. He'll be free to go before his next meeting. Thank you, Min. That's excellent.
Thank you.